So good morning. In continuation of previous video, that is 8051 architecture. So I'm going to explain overflow flag. So I was explaining PSW register overflow flag. See, alternate name is PSW.2 used in arithmetic instruction. It is set to 1 when the result of signed operation is too large. Again, we divide the binary numbers as signed numbers and unsigned numbers. Signed number means we give preference to the sign, either positive or negative, but in unsigned number, we won't give the preference. All the bits are representing the magnitude. So it is set to 1 when the result of signed operation is too large, otherwise it is 0. So for 8-bit number, the range of signed number is -128 to +127. That means only 7 bits are representing the magnitude and MSB represent the sign. If it is 0, positive, and if it is 1, negative. And if it is unsigned, all the 8 bits are representing magnitude. I mean 8 zeros to 8 ones. So in decimal it is 0 to 255. So again consider the previous example. Now see, it is unsigned number. If it is unsigned number, in decimal 98 means 152, 88 means 136. If you add, we are expecting 288. So 288 is an out of range. Right? So unsigned number is 0 to 255. So 288 means out of the range. This is called overflow. This is called overflow, in general overflow. So for unsigned number, we use carry flag as an error indicator. Indicates the result is out of the range. Similarly, overflow flag is used for signed operation. I mean, if it is less than 127 or greater than 128. Less than 128 and greater than 127. So in general, carry flag is used to detect errors in unsigned operation, and overflow flag is used to detect errors in signed arithmetic operation. And the next one is unused user defined flag, reserved for future. And the next one is parity flag, P flag, parity flag. So parity, I mean alternate name is PSW.0. So it shows the parity of register A, that means accumulator. So only parity flag applicable to only A register. It won't be applicable to any other registers. Reflects the number of ones in an accumulator. Parity means number of ones. If it is odd number of ones, the parity is called odd parity. If it is even number of ones, the parity is called even parity. So it is set to 1 if it is an odd parity, that means odd number of ones. I mean register A contains odd number of ones. If it is even parity, that is even number of ones, it is set to 0. Okay. This is about a parity flag. And these 4 are conditional flags. Now we'll see 2 other unconditional flags. They are RS1 and RS0. Register select bit 1, register select bit 0. That means, so in 8051 we have 32 working registers and they are grouped into 4 register banks. 4 register banks. To select one among the 4 register banks, we use RS1 and RS0. So select register banks as if it is both 00, it select a register bank a 0 and the address range is 00 to 7FH. Since 8 registers. If it is 01, register bank 1, 10, register bank 2, 11, register bank 3. So by default, register bank 0 is selected. So when we discuss internal memory organization, it will be more clear about the register banks. So time being, RS1 and RS0 is used to select the register bank. If it is 00, select register bank 0, 01 bank 1, 10 bank 2, 11 bank 3. By default, register bank 0 is selected. So apart from this, a microcontroller has 2 16-bit registers. They are program counter PC and DPTR. So DPTR, it's a 16-bit register. It can be used as an 8-bit register, DPL and DPH. Now let's see what is program counter. So program counter is a 16-bit register used to hold the address of next instruction to be executed. As you know, program whatever we write, so that will be stored in a program memory as an opcodes. So to fetch the opcodes we need an address, and that address should be stored in some register. That is, this is the register used to store the address of program memory. So opcodes are fetched from the memory which is addressed by the PC. After that, PC is automatically incremented to point the next instruction. That means whenever the current instruction is executing, PC is incremented to point the address of next instruction to be execute. And in 8051, so we have 4 kilobytes of internal RAM. 4 kilobytes of internal RAM, and the address range is 40H to 0FFH. But since program counter is a 16-bit, it can address from 40H to 4FH. My total memory size can be a 64 kilobyte. That means if there are 16 address bits, we can address 64 kilobytes of memory. So if the memory exceeds, internal memory address range is up to 0FFH. If it exceeds, automatically it points to external memory which has to be interfaced externally. And content, as I said, this instruction program counter holds the address of next instruction to be executed. It automatically increments, and that can be altered by an instruction called call and return instruction. These two are subroutine instructions. This alters the program counter. We'll discuss in detail so when we discuss call and return instructions. And remember, it is the only register does not have internal address. All the registers have their addresses. So we need to address A register, B register, PSW. So this is the only register which doesn't have internal address. And by default, it sets to 00 on reset the microcontroller. That is why it expects the first opcode of the instruction should be stored at the RAM address 00H. Now we'll see another 16-bit register, data pointer DPTR. It is a 16-bit register made up of two 8-bit registers. They are DPH high and DPH low. So 16-bit means again it is divided into two 8-bit numbers. So if it is in lower order, that is called low byte, and if it is high order, then that is called as high byte. So this register is made up of two 8-bit registers. They are DPH, data pointer high, and data pointer low. So it is used as an index register to provide access to the external memory. If it is a program memory, PC is used. If it is a data memory, DPTR is used as an index register to provide the address of external memory. So as I said, DPH holds the high order address byte, and DPL holds the low order byte of the address. So it can be specified as a 16-bit register, or it can be specified as an 8-bit register, DPH or DPL. And see, this is the only register, it has two addresses. Okay? Remember, DPTR is the only register, it has two, it doesn't have single address. It has two addresses. One is for DPH, that is 83H, and another one is for DPL, that is 82H. So this is about data pointer. And we'll see special function register RAM. As the name itself tells, special function register, it has a special role. Okay, some memory area is assigned for a special function register, that is called special function register RAM. Okay. So special function register means these registers do not use the addresses from 00 to 7FH, and it is for specific internal register. It uses the addresses behind 7FH, that is 80H to FFH. But again, some of the SFRs are bit addressable. As I said, individual bits can be altered. So all the addresses, 80 to FFH, all are not used. So again, in the instruction, either we can specify SFR as a functional name or by its address. Like A register is a special function register. We can specify it as a or it address 0H. TH0 means timer I byte 0. We'll discuss later. Its address is 80. So in instruction, SFRs can be named by functional name or by its address. So as I said, SFRs have special rules in 8051, and these are the special function registers present in 8051 microcontroller. These are the list of special function registers. So in the later sessions, later modules, we'll discuss the usage of all these registers. So this is about special function register. Okay, we'll continue in the next video about the RAM. Thank you.